welcome to video 3 in our 7-4 video series. In this video we're going to continue to look at exponential growth and decay, specifically some of the vocabulary that we'll be dealing with between these two types of functions. Now we've already gone over exponential growth and we came up with a formula that we derived from the compound interest formula. We replaced the n's with 1's and we got the formula a is equal to p times the quantity of 1 plus r raised to the t power. We haven't yet talked about the decay, but we are going to need to be at least a little familiar with it for all this vocabulary to make sense. We'll talk more about an actual decay problem in video 4, but in the meantime I want to go ahead and introduce you guys to the decay formula. So the only difference between the exponential growth and the exponential decay formula is going to be that instead of a plus sign between the 1 and the r, we are going to have a minus sign between the 1 and the r. And that is going to be because we are decreasing or getting smaller instead of increasing or getting larger. So it's going to be the same formula, but it's going to be p times the quantity of 1 minus r raised to the t power. Now, like I said, we're going to focus on some of the vocabulary in this lesson. It can get a little bit confusing because the words are very similar. We've already discussed that the growth rate is going to be the percentage of increase given. That is going to match your R value that we have been using in these problems. But we're going to talk about something that has a very similar name that's going to be the growth factor. This is the amount that's being multiplied repeatedly. You may also hear it referred to as the common ratio. We remember back to our geometric sequences, we talked about the common ratio quite a bit. But the difference between the two is the R value is just going to be the percentage. The growth factor is going to be the 1 plus that percentage. So I have the ant problem labeled over here, our results from above. Our R value, or our growth rate, will be that 1.5, or sorry, the 0.15 that we were adding. This is the growth rate. The growth factor will be the whole set of parentheses, where we are doing the 1 plus 0.15. Alright, so in our ant problem, the growth rate would be 0.15. The growth factor would be 1 plus 0.15, which is 1.15. So those are the differences between the growth rate and the factor. The growth rate is going to be that number that we're adding or subtracting. The growth factor would be that combined with the 1. Now, just as far as telling growth and decay apart, growth is going to have a number that is bigger than 1 as its growth factor. So for growth, I'll go ahead and make a note here. It's going to have a growth factor larger than 1. That is the only way that we're going to be able to get bigger numbers to increase. If we have decay, our growth factor will have to be less than 1. Alright, so let's look at this problem for example 3. We're given y equals 2 times 3 raised to the x power. So 3 is going to be our growth factor. It is the number that we get inside the parentheses. We don't have, notice, the 1 plus r. It's already combined for us to get 3. So our growth factor is going to be 3. What's going to be a little bit trickier is finding the growth rate. Now, this is going to be growth because this is a number that is larger than 1. It is a 3 on the inside. And we know that on the inside of the parentheses, that's really supposed to be 1 plus r. So if we were truly setting it up based off the original formula, it was supposed to be something like this. But we have already simplified it so that the 1 plus r was going to be 3. So to figure out the growth rate, we have to think, what do we add to 1 to give us 3? Now the obvious answer should be 2, so that's going to be our growth rate. But in case it wasn't something that was so easy to discover, all you would have to do is set the 1 plus r on the inside equal to 3 and solve the simple equation. We would subtract 1 from both sides and we would get r is equal to 2, the same thing as our growth rate. So we have figured out that this was growth, again just in recap because that was bigger than 1. Our growth factor was 3 because that was the entire set of the parentheses. That was when we already did the 1 plus r. And we figured out our growth rate because our 3 had to come from 1 plus r. The only thing we could add to r to make it 3 was 2. So let's go ahead and look at example 2. This one's laid out a little bit differently. This time it has it broken apart between the 1 and the r instead of going ahead and combining it. This does make it really easy to see that this is going to be decay since we are subtracting on the inside. It's also going to make it really easy to see our growth rate. Our growth rate is going to be that 0.6 that we are subtracting. Anytime you can get your r right away, that's going to give you what your growth rate is. Now to figure out our growth factor, we need to actually go ahead and simplify that. So we're going to take 1 minus 0.6, and that is going to give us 0.4. Alright, so that wraps up video 3. We do have one more video to look at. We'll look at a little bit closer example of exponential decay. For now, go ahead and give these U-tries an attempt. Make sure you check your answers, and then come back for our last video. Alright, see you guys then.